to, I wanted to make a little video for you guys of what we went over in class today so that I can help you with your homework even when you're at home. Don't think of it as a haunting, think of it as a helping. So, as we discussed in class today, the most important thing to remember about the absolute value is that it is the distance to zero from a number. So if you want to figure out just the numbers and what these values are, we want to say, what distance is 5 from 0? Well, 5 is 1, 2, 3, 4, 5 units from 0, and so the absolute value of 5 is 5. And what about if we wanted to know what the distance to 0 is from -5? Well, then we'd start at -5 and we say 1, 2, 3, 4, 5. And well, what do you know? The distance from -5 to 0 is also 5. Now let's think of it in terms of an equation. And you can see I have a couple equations, but I'm not revealing the next one yet. So your first equation is the absolute value of x is equal to 5. So instead of saying that we have some value that we have to find the distance to 0, we don't know what the value is, but we know what the distance to 0 is. So we want to work backwards and ask ourselves, what numbers have a distance of 5 units to 0? That is the question. What numbers have a distance of 5 units to 0? Well, it is -5. That has a distance of 5 to 0, as we found out here. And +5 also has a distance of 5 to 0. Now let's look at it in terms of another equation. The number that has an absolute value of 5 is, the number is -5, or the number is 5. Again, the statement would be, the number that has a distance of 5 units to 0 is -5 or 5. You can continue solving it. Now that we have two equations, we can just solve as usual. X is going to be equal to -1, or x is going to be equal to 4. Now for an absolute value inequality, we still want to ask ourselves a question, of course, that reverts back to the definition, or a statement I should say. The number, or numbers, that have an absolute value that is less than 10. That's what we want to look for. So what are those numbers that have an absolute value that is less than 10? I asked you this question in class today, and these are some of the numbers that I got. 4, 5, 6, 7, negative, what was that one? Negative 9.22 repeating. -8, -5 would work, -6. So all the numbers that have an absolute value that are less than 10 are the numbers that are less than 10 and the numbers that are greater than -10. All of the numbers that you could possibly think of that would have an absolute value or a distance to 0 that is less than 10 are the numbers that are going to be less than 10 or greater than -10. Again, don't look for a pattern. Think of the concept. Now, that I know what the number could be, we're going to replace the number with the expression, and so we can solve this compound inequality. Oh yes, I forgot. This is going to be the and. Let me just back up a little bit here. It's going to be and because all of the numbers that are less than 10 and all the numbers that are greater than negative 10 can satisfy both inequalities. We're going to talk about that in a little bit different, at a different time, but just keep that in mind why I know that it's and. So now let's subtract 2 on both sides. I'm really sorry, guys. My brain is really struggling right now. It's getting late. It's time to have some dinner. Okay. So if I solve the inequality, it would be something like that. Going on the other side, 3x greater than negative 12, divide both sides by 3, and you get the x is greater than negative 4. And of course, we're going to have to graph this, so drawing a nifty number line. Remember, open dot is non-inclusive, and you really only have to graph your numbers that are the answers and maybe a 0 just in order to get a realistic scale of the relationship between these two numbers. So this is going to be about 2 and a little bit more. So let's see here. Sometimes I have to do the scales here for 2, especially when my brain is not working very well. Okay, here we go. There's about 8/3. And negative 4 is not included, and neither is 8/3. And we want all numbers that are greater than negative 4 and also less than 8/3. So there you go. There's your answer to one of the absolute value inequalities. Let's look at another scenario, kind of switching it up a bit. This time, we want to find out what are the numbers that are more than 25 units to 0 are, well, what are those numbers? Let's just think of some numbers that would have a distance to 0 or have an absolute value that would be greater than 25 units. Well, I could think of one, 26. 26 is 26 units away from 0. 27 units away from 0. 28, 30. These are some numbers that all have absolute values that are greater than 25. Let's think of it the other way. Negative 26, negative 27, negative 28, negative 30. Even negative 1 trillion is going to have an absolute value that is greater than 25 because the distance to 0 of all of from 0 or to 0 of all these numbers is more than 25. So in order to summarize these in an inequality, we want to think that the number could be greater than or equal to 25 or less than or equal to negative 25. That's going to be the compound inequality that summarizes all of these numbers. Now if I move the number away and replace it with my expression here, then I can actually solve for the inequality. It's really important in mathematics to come up with a system that you can break down each problem into the beginning step and then each continuous step, you're going to have a lot more success if you can figure out your system and look at things separately, almost ignoring parts of the problem until they're relevant and you have to deal with it. I wouldn't necessarily take that over to life, because sometimes if you ignore life's problems, they actually get worse. So not all of math is totally applicable to life. Ha 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 ha. Don't quote me on that. Ah, yes. Forgot to do something here. Forgot to switch the sign because I'm dividing by a negative. Probably should have made this video early in the morning when my brain was still working. Alright, so let's just make sure that I did everything correct, since I don't have any students to make sure that I did everything correct. It's just me now. Okay. Everything looks good, so let's just go ahead and graph it. So if that's negative 2.3, still a little bit further from 0 is going to be positive, oh my goodness gracious, 2.7. And so we have that any values that are greater than 2.7 and any values that are less than negative 2.3. Now at this point in the inequalities, I think some students get a little bit lost in the solutions and what a solution to an absolute value inequality means. So I just want to quickly talk about that. Let's go back to these let's take this solution for example. Let's take any number that is greater than negative 4, and we're going to plug it back in here and see if it's a solution. So any number that's greater than negative 4, well, negative 3 is greater than negative 4. What if we substituted in here? What if we said, if x is equal to negative 3, is that going to satisfy the solution? Well, let's see. If we have that this is negative 9 plus 2, keep in the absolute values, that's really important. And then negative 9 plus 2 is negative 7, so we're going to eventually take the absolute value of negative 7, which is positive 7, and that still is less than 10. So these solutions to this inequality means that you can pick any number in this inequality, in this solution, plug it back in, and it's going to make this statement true. If you pick any number that's greater than 2.7 or any number that's less than negative 2.3 and plug it back into this number sentence, you're going to get a true statement.